Thank you. It's a pleasure and honour to be here. I thought I'd describe what I'm up to from a commercial point of view. I manage some companies from inner city Sydney and somehow still have my personal research lab in a far eastern suburb of Sydney in San Diego. One of the companies that I spun out of Scripps in 2010 is called MRV Systems. It makes ocean robots, unpowered autonomous robots. One of the famous projects that we contribute to, we're one of 3 or 4 companies that make the robot on the left, which profiles the ocean down to 2 kilometres, measures the heat, salinity on the way up, last about 5 or 6 years, go up and down about 300 times, spend very little time on the surface, communicate through the Iridium telephone network to dump the data to a communal server that everyone in the world has free access to. So Australia, through the Bureau of Meteorology and until recently through CSIRO, has been one of the most steadfast supporters of this network, and we're a huge beneficiary of the data that comes from it. This network is really just the beginning. There's a huge program that many Australians have chaired committees for, looking at the biogeochemical side of the ocean. All of these measurements we could take from ships. It's just the darn taxpayers are so picky with what they'll fund that we have to find ways like this to do it robotically, that they're 200 or 300 times cheaper than doing it on a ship. Our company has been pioneering some new versions of this robot. We have, for the first time, air deployable versions of this robot. It's something that I pushed for in the Southern Hemisphere. Previously, we had to ease the robots off the side of a ship. That's just fine in the Northern Hemisphere because there's always a ship going somewhere in the ocean in the Northern Hemisphere. Of course, that's very untrue in the Southern Hemisphere. So we developed that air deployable capability. There's a new product video that's quite entertaining, we think. Unexpectedly, that's been a big seller with the cyclone and hurricane crowd. They've been dumping instruments right into the eye of hurricanes as they smash into Hawaii and other places. The other new product is a version that will lie on the ocean floor until triggered. It can lie there as long as you like. We say that we developed this for the whale researchers, so someone like my colleague John Hildebrand is able to identify individual whales from their songs, John and Mary. So you can program these robots to lie in the ocean until that whale goes past, then come to the surface, send a little email back to the lab, literally an email that says, I heard John going past and southwest at 2.5 knots. Obviously, other grey cylinders in the water can be detected with these, and we sell to that market also. One of the most amazing results that this data has contributed to, along with ancient ship data, is this very important graph, which I think is the most important picture of what global warming is. This shows where the 250 zettajoules of energy that CO2 and other pollution is trapped in our planet. And 93% of that goes into the ocean. And so if you ever wondered why my institution, Scripps Oceanography, started doing the CO2 measurements in 1958, it's not because we wanted to become an atmospheric science institution, although we did become that. It's because my very famous predecessor, Roger Revelle, realized that all of that heat, if we were lucky, would go into the ocean. And Roger actually hoped that the CO2 would dissolve in the ocean and mineralize. It's very easy to figure out that's the correct thermodynamics, but unfortunately, the kinetics takes about 10,000 years, and so we still have the global warming issue. So you can see the top of the ocean, the middle layer of the ocean, 93% of the warming, a couple of percent into melting glaciers that are currently on land, a couple of percent actually heating up the land surface, and a tiny fraction, less than 2%, heating up the atmosphere. Now, if you follow the popular press, of course, because we're mammals that live in the atmosphere, except when we go for our morning swim, you hear most about this tiny 2%. But the thing that's going to affect Australian agriculture and the demand for air conditioning in Western Sydney and Melbourne is all the way in which that heat goes into the ocean, how it sloshes around between the ocean and the atmosphere, and how quickly it's absorbed. So 2 things on that. One of the things I hope to contribute to the academy and our chief scientist and so on, is explaining that far from needing fewer scientists in this area, we need to build up a greater capability of people that understand this data, thermodynamics, the basic science of climate change, and figure out how it's going to impact our industries all the way from tourism at the Barrier Reef to soil moisture and agricultural industries, and how we'll have to change our crops and agricultural processes over the next 3 or 4 decades. The second thing is that there's a great new experiment that the global community is trying to do, and that's called DeepArgo. We tend to lose track of this heat below 2 kilometres, which is the current depth of the current geometry robot. This is a round robot that's been designed to go all the way down to 6 kilometres. Great stresses on our technology, since we never see these things, we never recharge the batteries. They're designed to last for 5 years and come up to the surface. So we're trying to raise money around the world to fund 300 or 400 of these robots, which is what we think we need. Until recent events in the United States, we were looking pretty good for the first tranche of funding from the United States. So that's the first company. I mean, I guess the other thing is I started this company in the United States, but you know, we could have started it in Australia, and I think it's a great lesson of, you know, why didn't we? What's missing from Australia? Now that I'm back, I'd like to help with that discussion. The second company is one that I've developed with my former CSIRO colleague. Many of my other colleagues are here. I was lucky enough I loved every day in CSIRO. I was lucky enough to join in what we now call the good old days. This is Mehrdad Baghai, my colleague at the time, and I convinced Mehrdad back in 2002 that algae was the wave of the future. Somehow he's a slow learner, and he still believes that. And so we have an algae-based technology that we've licensed from my colleague, Dr. Mark Hildebrand, also at Scripps, silicon-regulated algae tricks, in order to make products in the animal health market. And that's a company that we've established in Australia. We intend to use the natural advantages that Australia has. This is a picture of our business partner who has a pilot-scale facility in Hawaii. We've targeted this vaccine technology because we think there's a lot of low-hanging fruit, if you'll excuse the expression, in Australia. But we can also make food for aquaculture, prawn farms, for example, something that Nigel Preston taught me at CSIRO. And also we can make fuel if we ever have a emission trading scheme again, and we've recognised the value or penalty of CO2, then we can make very nearly CO2 neutral fuels using this technology. And the last project is more in the pro bono category, and much more difficult than anything I've talked about. This little guy here is the vaquita, the world's smallest dolphin. Lives only in the northern Sea of Cortez, or what the Americans call the Gulf of California. This poor little guy, through no fault of its own, is greatly endangered. My scientists at Scripps tell me there's maybe only 60 left, which is a very bad place to be. And if I told you the story of why it's come to be endangered, you probably wouldn't believe me. But let me tell you that Chinese herbal medicine is involved. Drug gangs in Mexico are involved. This green region here is the mouth of the Colorado River, and we work very closely with the indigenous people that inhabit that region. Their life was turned on its head in 1920 when the Hoover Dam was turned on and suddenly their water supply was turned off, and the breeding grounds for the totoaba, another fish that they catch. But in summary, it turns out that the poor little vaquita happens to be exactly the same size as a fish called the totoaba. It's like a croaker fish. For some reason, the mythology has gone around that the swim bladder of that fish, when dried and ground up, is an aphrodisiac in Chinese herbal medicine. There's an illegal drug trade in these grounds. Of course, scientifically, it does nothing. It tastes horrible. It has no effect, as far as I can tell. And it's a terrible tragedy that this mythology. Nothing we can do, of course, can convince the illegal gangs that there's absolutely no value to this as a medicine or a cure. So the technology that the illegal fishers use to catch the totoaba happens to trap these darling little vaquitas, and they just kill them and throw them overboard. So why do I mention this as sort of the commercial point of view? Well, we're working with a bunch of people that we actually met through the Mexican-American illegal trafficking of human beings, where we developed some confidence over the years. Very important politicians in Mexico, 3 local state governments from the states of Mexico around the Sea of Cortez, to try and establish a legal economy that would eventually take over from this legal trade. So it's building up a little bit of tourism, a lot of bit of sustainable fisheries, finding direct ways to market. You see up here, San Diego is on the top left here, so it's only a 4-hour drive from these indigenous villages to San Diego. If we had ice, we need electricity, but if we had electricity, ice, trucks, we could get quite a valuable, nice fish to market and begin to replace this illegal economy with a legal one. So thank you. It's a great pleasure to be here, and I look forward to working with the Academy.